Hello everybody, Chris F.E. Jackson here. Right, I meant to do this one yesterday prior to the other snippet I did by Jonathan Amos regarding the constellation of the satellites. So this one, he was out the day before on the 12th of January, and it says citizen science bags 5 planet haul. Wow. What's that all about then? Well, I'm going to tell you. Artwork. The findings could shed light on the process by which planets form and then migrate within their systems. So there you are. Here's a sun, some other things, and a planet. I don't think that's Earth, but it says NASA. This artwork, but that's by NASA. But we're talking about citizen science here. Oh, I digress. A discovery by citizen scientists has led to the confirmation of a system of 5 planets orbiting a far-off star. So we've got some more people. I just knew there'd be some more coming soon. Far off people. It's far off. It doesn't say how far, but far off. Furthermore, the planets' orbits are linked in a mathematical relationship called a resonance chain. Now that's a new one on me, a resonance chain, with a pattern that is unique among the known planetary systems in our galaxy. With a pattern that is unique among the known planetary systems in our galaxy. So this mathematical relationship, which is called a resonance chain, is a pattern that's unique. Well, you did well to find that then. Oh, it's unique. Oh. All done by citizen scientists. Studying the system could help unlock some mysteries surrounding the formation of planetary systems. Yes, if they're not unique, right? The results were announced at the 231st American Astronomical Society meeting. Oh, they had to get out something rather major, I guess. Oh, we've got this, we'll keep that one back for the meeting, for the 231st meeting. We've got something to say. Look, this is what we're doing. The system was found by astronomy enthusiasts using Zooniverse. Zooniverse, I've never heard of that. But then I learn something every day, I think. Zooniverse. I think they should have called it Looniverse. Anyway, an online platform for crowdsourcing research. Crowdsourcing research. Well, that sounds good. I'm going to have to look into that, people, so please bear with. Oh, look. People anywhere can log on and learn what real signals from exoplanets look like. Wow, I'm really intrigued with that. I'm going to have to look, yes. And then look through actual data collected from the Kepler telescope to vote. No, this is vote? Vote? Well, what? Vote on it? You don't vote on whether data's good or not. You dissect the data, you look at it and you digest it and then you compare. You don't vote on data. I mean, if I went round saying that, I don't know, I said my bank account has got £10 million in it. It's the correct figure because we all voted on it. So there you are. Okay, to vote on whether or not to classify a given signal as a transit or just noise, said co-author Dr. Jesse Christensen from Caltech in Pasadena. Since the discovery of 4 planets in this system was announced last year, Dr. Christensen has been working to shed further light, no any pun intended, on this distant planetary neighbourhood, dubbed K2-138. I take it this isn't the TRAPPIST-1 stuff, but there you go. This led to the discovery of the 5th planet, and hints of a 6th. So yes, more work, people, more work to be done. All the worlds are a bit bigger than our own planet, ranging between 1.6 and 3.3 times the radius of the Earth. Right. The collected findings have now been accepted for publication in the Astrophysical Journal. The collected findings have now been accepted for publication. Yes. Did they vote on that? Perhaps. The raw data used in the discovery was provided by NASA's Kepler Space Telescope, which identifies potential planets around other stars by looking for dips in the brightness of those stars when planets pass across their face or transit them. Yes, I think we all know how they get these exoplanets, and they look for these little blips that are millions and billions of light years away. But I digress. Links in a chain. Being in a resonance chain means each planet takes almost 50% longer to orbit the star than the next planet further in. Well, a resonance chain. Okay, so wouldn't that depend on how big the planet is and how further away it is from the first planet or the next planet or from the actual sun? Would you not need to know that first? Intriguingly, the sixth planet skips 2 slots. Oh, so now the sixth planet does exist now. Right, okay. Intriguingly, the sixth planet skips 2 slots in that resonance chain, taking much longer to orbit the star than it should if it's simply the next planet up from number 5. If you keep going with the resonance chain, yes, you skip 19 days, you skip 27 days, and you end up at about 43 days, said Dr. Christensen. That's a really tantalizing clue that we may be missing more planets in this system. If this chain continues, there's a gap. Is that a gap in the data, or do you need to revisit that just to make sure that your times and your data is correct? I digress. It's not the only system to exhibit resonances. Okay, so this isn't unique then. There's something else, other resonances happening then. There's a resonance chain. The orbital motions of 7 planets in the TRAPPIST-1 system are linked in a complex chain. In the time that it takes for the innermost planet to make 8 orbits, the second, third and fourth planets revolve 5, 3 and 2 times around the star respectively. Make of that what you will. It's just annoying me now, sorry. But the way the chain is configured in K2-138 is different to TRAPPIST-1 and unique among exoplanetary neighbourhoods. The near-resonant chain, so it's not a resonant chain, it's a near-resonant chain now in TRAPPIST-1. It's those that have formed as the planets migrated inwards toward their parent star after formation early in the system's history. Can you feel the pain? So K2-138 could yield further clues to the process by which planets form and then migrate from their original positions. This is a particularly contested area with several competing ideas. Well, I think what that means is that you can't agree on everything and the voting isn't going the way you want it to, is it? Some current theories suggest the planets formed by a chaotic scattering of rock and gas and other material in the early stages of the planetary system's life. However, these theories are unlikely to result in such a closely packed, orderly system as K-138, said Dr. Christensen. Yes, good for you. What's exciting is that we found this unusual system with the help of the general public. The general public, yes. So how did you get the general public to actually assist in this? Well, let's go to Zooniverse. And I have the link up here already prepared. And here we are. Zooniverse. Let's just see all projects to start with. Let me see how this looks. Come on. I'm going to have a look for the exoplanet stuff. Come on, what's happening? If I go down, oh, let's go to 2 then. What's this? Oh, mapping change, camera catalogue, snapshots of scene, measuring the answer, science gossip. I thought that's what I was doing. Anyway, let's go back to 1 then. I had this up now. This is just so annoying. Right, where are you? Come on, you are here somewhere. I didn't know elephants went on expeditions. Oh, yeah, the plastic tide. dear. I'm not getting very... Oh, did I miss it? This really is annoying. I knew I should have kept it, but I wanted to do it in real time. I'll try this again. That can't be it, surely. Let's go to active projects, because it should be active. I thought it was a science. Oh, okay, let's go for all disciplines. Please bear with. Oh look, now I have 4 options now. Sleeping birds, look. Right, okay, if I skip to the bottom. I did 2, didn't I? Let's go to 3. Oh, supernova hunters. Been there. Oh, getting close, people. Comet hunters. I'm sure we are. Go away. Let's have a look. Come on. Oh. Right now, it must be number 4. It must have been number 4. Radio Galaxy Zoo, Planet 4. It could that could be the Planet Hunters. I'm just going to check down here. Yeah, let's go for Planet Hunters. Is that the one? No, it says light curve changes, not light dimming. No, it's taking me to another website. Oh, this really is annoying me. Have a little back there, people. I'm just going to pause this until I get the correct place. Right, due to the magical powers of editing and time, here I have it. It's called Exoplanet Explorers. Discover new planets orbiting other stars in our galaxy. Learn more. Right, and I'll just see if I can scroll down here. Is there any other information? No. And I'm not sure if you can see that, but these are the type of data that they're crunching. And oh look, 20 people are talking about Exoplanet Explorers right now. Yes, 20 people. Oh, they're busy. Shall we learn more? I am up for learning more. Okay, let's have a look. Right, what do they say? Oh look, some pretty pictures. It's not the one I wanted, to be honest. Oh, classify. Now, how do they classify what an exoplanet is? Please bear with me on this, because this is going to be it, really. This is all I wanted. This is all I'm going into on this. I'm going into no maths. I'm going into no dissection of the material that's shown. This speaks for itself, and I need not go any further. Welcome to Exoplanet Explorers. The graphs you see here are known as light curves. Does light curve, or does it travel in straight lines? These show the brightness of a star over time. Right, so when they say light curves, it's the brightness which dims and it comes back again. So the level and the exponential, if there was an exponential change, then it would create a curve of the intensity against time, but it's not the light bending. If a planet passes in front of a star, it will block some of the light. That's very scientific, isn't it? Some of the light. Causing a dip in the light curve. Now this is really annoying me. I want to slap somebody's face. This is called a transit. Okay, I shall continue. What I'm looking for in these graphs. The graph on the top right is known as a folded light curve. This is made by plotting all of the individual transits on top of each other. If there is a planet transiting the star, you will see a dip in the folded light curve at phase 0.0. Oh look, there. So as a citizen scientist, they're telling me what to look for, and oh look. Now, I would have thought a computer would have been able to do that, as opposed to somebody looking at a screen and a graph. Oh, look, I found one, people. Hey. Yeah, right, okay. Continue. What am I looking for these in the graphs? The graph on the bottom right is a zoomed in version of the folded light curve. Right, so that was the 0,0 phase. That's the phase angle, is it? Phase angle of what? How many? Bananas? What's this axis here in what? Apples? I don't know. Intensity in what? Lumens or what? You say it's raw data and you generate this from raw data. Come on. The solid blue line in this graph is a computer model prediction of the shape of the transit. Is a computer model prediction, people, of the shape of the transit. If this line fits well with the dots, you've probably found a transiting planet. Yes, from the computer model prediction. So you're looking at data, which they tell you is initially as raw data from the Kepler telescope, right? So the data, you're not getting this data straight from the Kepler. You're getting this data secondhand, which has been chewed and spat out to a website for all and sundry to perhaps look at and crunch maybe data or whatever. And this could be just an exercise and you're just getting everybody sucked in. Anyway, last one. Before you get started, we have included some simulated data in the project. This means that some of the graphs are generated by a computer rather than being real observations of a star. It is important to include simulated data as it helps us understand our results. If you classify a simulated light curve, you will see a message letting you know this when you click done, and you have been. If you'd like to see more examples of what you're looking for, please have a look at the field guide on the tab right. Let's go. No, thank you very much. No, thank you. I'll just say let's go to see what happens. There we are. Okay. Look at this. All right, people. The website. You can have a look at this at your own leisure. Zooniverse.org, and I'm sure there are hundreds of people looking at this. I did see one web page with all the names in text format. So individual. I'm not going to say any more. Well, thanks very much for watching, and yes, it's been rather enlightening to see these light curves. Okay, signing off now. Thanks, people. Bye bye.